Next example. So again, we have here an example of stress and strain diagram. So we have here a tension test was performed on a specimen of 12.5 millimeter diameter and a gauge length of 50 millimeter. The data are listed in the table. So again, the data here is in terms of P, and in terms of delta. So practically, again, sigma and epsilon were derived by dividing this P by the area, utilizing the given diameter of 12.5 millimeters. See, the area is equal to the area of the circle pi all over 4 times 12.5. This is squared. And then again, epsilon is obtained by dividing these values by the gauge length of 50 millimeters. Okay, so out of that, they have come up with these values for sigma and epsilon. So these are simultaneously graphed again using the points. What is interesting here is that the first point was located here within the straight line, and the other point jumped on the boundary on the curve line. So as a continuation, so this is just projected on this area until it reach the peak, until the fracture point. Of course, the last point is always the fracture point here. And then, well, this peak here is easily determined, and the fracture point could be easily obtained by projecting it horizontally in order to determine this one. So this one is the yield stress or yield strength equivalent to 528 megapascal, readily available when you graph it. And then for the fracture point, or the what we call fracture stress, that is again horizontally projected, we come up with 479. So again, for the approximate value of the modulus of elasticity, the same principle was adopted on the first example. So what they did is to have the first point here and then pass through this one and then project it. Okay, as we can see, this straight line could be terminated here because we cannot really extend it in that way because it will not pass through this point. So again, this is an approximate technique in determining the point of transition between the straight line and the curved line. And again, those lines were projected horizontally and come up with the sigma values and the epsilon values. Okay, So we know that the Young's modulus of elasticity is equivalent to sigma all over epsilon. That is why we have here the values. Okay, so finally that was computed to be 229 gigapascal. So this is the problem all about. Again, this is more on graphical method. So perhaps we can proceed to another video for the third problem.